Hey everyone, coming live to you from Long Beach, New York. We are going to learn our next lesson, which is going to be called Day 5, Chapter 8, Notes, Day 5, Margin of Error and Sample Size. So first thing, I have the answer key rubric for the homework from last night. So I will be posting this and you can check it out and read the rubric to see how you did. Then you see there's a question here that I want you to try. Obviously, it's filled out on my end, but I want you to do this question for your Do Now. The Harvard School of Alcohol Study is spotlighting binge drinking. Try this. Sorry, try this question. Write all the information on the top and do the full panic procedure. Okay, so now let's go to day 5. So today we're talking about margin of error and what impacts the margin of error of a confidence interval. So if you remember back to your reference sheet, the confidence interval formula is confidence interval equals statistic plus or minus critical value, which is CV for short here, times the standard error of the statistic. The margin of error is the piece after the plus and minus. So the things that affect the margin of error are the critical value, which is Z star in this case that we've been doing, and the standard error of the statistic. Now, in this last few days, we've been doing the standard error of the statistic of P hat. So remember that formula is the square root of P hat times 1 minus P hat over N. So the things that also impact the margin of error then are the value of P hat, because that's playing a role in this question, and the size N, sample size. And you guys know that sample size plays a role in everything we do. So let's say I wanted to decrease the margin of error, basically having less error present when I'm doing my interval, because who wants so much error, right? So if you want to decrease the margin of error, you can decrease the confidence level. That's number one. The confidence level is C. Okay, so remember the confidence level, let's say, was 95%. That's going to be a wider interval, which is notated here. And the margin of error here is going to be a lot bigger versus an 80% confidence interval width is going to be less. You're going to be less confident, but there's going to be less error. So if you decrease the confidence level, you will decrease the margin of error from here to here. Secondly, this one is pretty important. The sample size. You guys know N is the sample size. Remember, as the sample size increases, the standard deviation decreases. As N increases, standard deviation of the sampling distribution decreases. This is because, remember, if you look back at this formula, that N is in the denominator of the fraction. So if you increase the sample size, you're increasing the denominator. And if you increase the denominator, you are decreasing the overall value of the fraction. So as you increase the sample size, the margin of error will decrease. And it will become narrower of an interval, or skinnier, okay? So these are the things that we need to know moving forward. So here's an example. As part of a project, Ellery surveyed a random sample of 25 students, so that's her N. One of the questions she asked was about, what's your GPA? So she asked them to say their GPA out loud. So I'm hoping you're already thinking about this could be biased because people could lie, and that's called response bias. People probably feeling judged, and they lie about their GPA. And in fact, they're probably going to report GPAs that are a lot higher than they really are. All right, so now based on the responses, Hillary said she was 90% confident, so that's her confidence level. And she got an interval of 3.14 to 3.52. Now, when you guys go to college, the GPA is going to go up to 4. So 3.14 to 3.52 is pretty good. So that's basically saying people lie. Explain what would happen to the length of the interval if the confidence level was increased, okay? So if the confidence level increases to 99%, I want to show you how this plays a role on your reference. So on your reference table here, you're going to see on the bottom row is the confidence level, C. And in this case, we were going from 90% to increase it to 99%. So if you look at 90% here, the Z star is 1.645. If you look at 90, let me just write that down. Z star equals 1.645, so that one, 90%. If you look at 99%, which is right here, basically you're going to be more confident. You're going to be 99% confident instead of 90% confident. So your Z star is going to go up to 2.576. If your Z star goes up, think about that margin of error formula if you go back to the last page. So the Z star is this critical value here. So if the Z star goes up, this is Z star, standard error of P hat. If the Z star goes up from 1.645 to 2.576, that's going to make this value bigger. And it makes that value bigger, that makes that whole product bigger. And if the product is bigger, the margin of error is bigger. So explain what would happen. Basically, the width of the interval will increase, it will get wider, and the margin of error will increase. So there's more room for error. How a 90% confidence interval based on a sample of size 200 compared to a 90% of the original interval. So the original interval, if you recall, was 25 for the sample size. And now we're going to increase it to a sample of size 200. Okay, so remember we said on the previous page, if we go to the second bullet point, as we increase the sample size, the standard deviation decreases. If the standard deviation decreases, the margin of error gets narrower and the interval gets narrower. So this will decrease the margin narrower interval. Less error present. So we always want a bigger sample size. Always. Okay, so that's that question there. Now, sometimes at AP, they're going to give you some information where they're going to give you the margin of error that you want to kind of be within, and they want you to choose the sample size, which is the N. You want to find the N that is going to allow us to be within this margin of error that's given to us. So they'll probably give us the confidence level, C, and then we'll get the Z star, and then they'll give us a specific margin of error they want us to be within. So this less than or equal to means within this given margin of error, okay? And basically what we have to do is try to solve for it. So what this says down here is if you don't have P or P hat, sometimes you have to pick a value for P hat as well. So I'm going to show you on the next page. And I'm going to explain what this means in a second. So let's look at an example here. This is the bull wants to conduct a poll, estimate 95% confidence, so let's see. The proportion of students, that's the parameter, in her school who have jobs. Okay, so the confidence level is 95%. If you were to look up the Z star for 95%, you're going to get 1.96. So we need that. How large of a random sample, so they're asking you what does N have to be to obtain a margin of error of at most 0.05. Okay, so they want the margin of error, ME, to be within 0.05. Okay, so basically, you have to solve for that N, which is the sample size. So remember the formula for margin of error is Z star times sigma of P hat. In this case, P hat, 1 minus P hat over N. We want this to be less than or equal to 0.05. So we know Z star, we can plug that in here. That's 1.96. Now, the problem is we're solving for N, which is in the denominator. They didn't seem to give us the P hat value either for the sample proportion. We don't know P hat, okay? So basically, if we don't have P, we usually use P hat in this place. If we don't have P hat, we have to just guess a value for P hat. And some textbooks call this P star. What is P star, you ask? It's 0.5. So on the previous page, it says if you don't have P or P hat, you're going to use P equals 0.5. Okay, so 0.5, you're like, what's up with 0.5? Why would we pick that? Well, if you do P hat times Q hat, 0.5 times 0.5, that product, 0.5 times 0.5, is actually going to be the largest of any other combination of P and Q. So if you had 0.5 times 0.5, you're going to get 0.25, okay, for the numerator here. But if you had any other combination of P hat, if you had 0.4 times 0.6, that's going to be 0.24. If you have 0.9 times 0.1, that's going to be 0.09. Basically, there's not going to be any other product of P and Q that's going to equal anything bigger than 0.25. So this 0.25, this 0.5 times 0.5 is considered a conservative estimate. We're basically overshooting the margin of error because we don't know the value of P hat. So we don't have P hat, so we're going to use 0.5, all right? So let's just write that down. If don't have P or P hat, use 0.5. That's where that came from there in the numerator. All right, so now we're actually going to solve them. This is going to become the most mathematical thing that you do in here, basically, because you have to solve for n. And the n is located right here in the denominator of the fraction. So how are we going to solve and isolate that? So I'm hoping you said divide by 1.96. I'm not really going to round to the very end here. Now I'm going to do 0.5 times 0.5, which is 0.25 over n equals whatever this is. I'm just going to leave it like this, okay? Now, how do we get rid of a square root? Well, I'm hoping you're going to say square both sides. So then you're going to have no more square root on the left. You're going to have 0.25 over n is less than or equal to this number. Okay? So now I'm going to go to my calculator. I'm going to plug this in. I'm going to see. All right, so I put this in my calculator and I got 0.05 divided by 1.96 squared. I got 0.00065,077, blah, blah, blah. Okay, just write it all out. Okay, don't round it. So now this is going to be 0.25 divided by n is less than or equal to this number. So my next advice would be multiply both sides by n to get that n out of the denominator. Okay, so we're going to have 0.25 is less than or equal to that crazy number, 0.00065,077 dot 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 n. And then the last step is going to be divide by that number. And again, I don't really recommend that you round early. I think you should just round at the very end. Okay, so let's see what we get. We're going to get n is greater than or equal to, let's see, divided by 0.06. I got about 416.67. Okay. Now, if you read this from the left to right, it says 416.67. But if you read it from right to left, that really means that n is greater than or equal to 416.67. Now, remember, n is the sample size, and that's the number of people. So we can't have a decimal amount of people. So in this case, we're going to round up because it says greater than sign. So it's going to be 417 people or more. So if you go back to the question said, how large of the random sample must we be to have our margin of error be within 0.05? So basically, that would be 417 people or more. I'll write it over here, 417 or more people for the sample for this to be met. Okay. Now, let's go back to the next one, Skippy. All right, so now, if you look at this next document here, these are the AP questions that are related to this. So let's do a few, and that'll be that. These are multiple choice, as you can see. It seems like they put like one per year on this. So it's not like a very heavily tested question, but it is important to try it. The manager of a car company will select a random sample of customers to create a 90% confidence interval. So let's write 0.90. Then let's go to our reference sheet. And let's remind ourselves that 90% is 1.645 for Z star. To estimate the proportion P of customers who have children. Of the following, what is the smallest sample size, N? So we want N, the smallest N possible, to make the margin of error no more than 6 percentage points. So we want the margin of error to be no more than 0.06. So first thing is 6 percentage points as a decimal is 0.06. So you got to put that there. Now we're going to write our formula for the margin of error. So margin of error formula is Z star times sigma P hat, which is P hat 1 minus P hat over N. If you plug in what you can, you will plug in Z star here, which is 1.645 times, and then do you see they didn't give me P or P hat? So because of that, I have to use P hat equals 0.5, which some textbooks call it P star. So you're going to put 0.5 times 0.5 over N, we don't know N, is less than or equal to 0.06. Now, the nice thing about this is because this is a multiple choice question, technically you could plug in all the choices in for N. If you like that route, plug in 100 in for N, see if it's less than or equal to 0.06, plug in 125, etc. And go through all the choices, plugging in for N and see which one will give you this margin of error within 0.06, okay? That's option one, is plug in for N. Option two is actually go and solve this out like I just did with you. So what you would do first is divide by 1.645 on both sides. Then you would get square root of 0.25 over N is less than or equal to 0.06 divided by 1.645. Then you would square both sides. So we get 0.25 over N is less than or equal to whatever this is. And then I would multiply both sides by N to get rid of the N out of the denominator. And then I'm going to get 0.25 less than or equal to whatever this is, squared times N. And last step would be to divide that whole thing out and leave the N alone on the right. So let's just put this in the calculator and see what we get. All right, so as you can see, I did 0.06 divided by 1.645. Whatever I got, I squared it, and I got about 0.00133. Then I divided it to the other side, and I got N is greater than or equal to 192-ish. So the first sample size that's greater than 192 out of the mix is choice D, 200. So let's say you had done the plug-in method. I'm hoping that when you plugged in 100, for N, it wouldn't, and when I say plug-in, I mean go to the choice 100, plug in 100 in here, see if this thing equals less than or equal to 0.06, etc. I'm hoping that you realize that the one that works is 200 is the first sample size that's big enough that it will be less than or equal to 0.06. Now, if you look at the next one, 2012, number 9, it's slightly different. So it gives you a random sample of 900 adults, and it says that they reported that 60% of adults in the US are in favor of increasing the minimum wage. So this time they gave you the value of what to me sounds like P, the true proportion of people in the country who favor, and that's because it says all adults in the United States. They took a sample of 900 though, so I think that might be P hat because it seems like it's based on that sample of 900. If the reported percent has a margin of error, ME, of 2.7 percentage points. So now remember, 2.7% as a decimal is 0.027, which is the closest to the level of confidence. So this time they're not asking you to solve for N because they gave you N 900. This time they're asking you to solve for the confidence level. So if you remember, the formula for margin of error is statistic, which is, sorry, not statistic, plus or minus critical value Z star times standard deviation of the statistic, which is square root of P times 1 minus P over N. They're telling me that this margin of error equals 0.027. So we know that on the right. Z star we can, we don't know. And actually Z star is what's going to be the unknown here because we don't know the confidence level. So we're going to leave Z star. P hat they gave me was 0.60. 1 minus P is 0.40. and they gave me n, which is 900. And this time we're going to solve for z star, okay? So plug this whole thing in the calculator and see what you get. And then you're going to divide that to the other side, basically, and then you're going to get z star. So for this value, I got 0.0163. If I divide 0.027 divided by 0.0163, I got about 1.65, okay? 1.65, that is Z star, okay? So now I want the confidence level, so I would look at my table to see which Z star is closest to 1.65, and look, it is 90%. There it is, 1.645. So that is the answer. Okay, so there's plenty of these to do. Seems like there's one of each. They are pretty algebraic. It seems like there's one for each year. There's some that involve using the formula. There's some that involve solving for n. But at least hopefully you see how this is used on the AP test.